Least common denominator is, well, we got to include a factor of 2, and we got to include a factor of x minus 7, right? So we're going to take the least common denominator idea of 2 and x minus 7, and we're going to multiply that through the entire equation. So we're multiplying to both sides here. I'm just going to write it like this, though, because of the space I have available. I'm taking this idea, in theory, multiplying it to both sides. Now, as you multiply this through, we appreciate that this is essentially over 1 that we're multiplying through, meaning common factors between numerator and denominator for these new fractions that are forming will cancel out. So for instance, I take this idea here, I multiply the x over 2. Factors shared between numerator and denominator would be the 2 and the 2, so those would cancel out, which is the whole point, because we want that 2 to go away. We don't want that fraction there. Meaning what's left over is the x, and only these 2's canceled, meaning x minus 7 is still there needing to be multiplied. That's the adjustment we make for this first fraction. We then subtract. Okay, I'm now taking this 2 times x minus 7, multiplying to this fraction here. Common factors shared between numerator and denominator would be x minus 7, so those cancel out. If these cancel out, all that's left to multiply through is this 2. So it's 2 times the 9 minus 2x on top. Right? That numerator, that stays in there. We're just canceling out these denominators as we go. Okay, that equals, I take this 2 times x minus 7, I multiply to 5 over x minus 7. Common factors of x minus 7 cancel out. All that remains, 2. 2 that gets multiplied to that 5. Which, yeah, I know it's 10, but there you go for dramatic purposes. If I start multiplying some stuff out so I can solve a little more easily, I get x squared minus 7x. Distribute negative 2 through here, so it's minus 18 plus 4x. That all equals 10. I've got this quadratic that's forming, so I should probably start shifting everything over to one side. I've got the x squared over here. Combine my like terms of negative 7x and plus 4x, get negative 3x. Bring that 10 over, subtract it over, get minus 28 when it joins the negative 18. That all equals 0. From here we try to factor. Trying to factor. Got x times x giving us x squared. Okay, minus 7 plus 4, that's a good combination to use to create that negative 28 as well as that negative 3x. We've got our two factors here, each of which we're setting equal to 0 to solve for x, meaning x is going to equal, well, it's going to equal 7 from the first factor, and it's going to equal negative 4 from the second. The last thing we got to do is check for extraneous solutions. So do we have any extraneous solutions here? Do we have any issues? We do have an issue. We should notice that when we take 7 and we plug back into the original equation here, the 7 goes in the place of this x. That gives us 0 in the denominator. We can't divide by 0. We got to take this answer out. Now, for negative 4 is not going to create that kind of issue. So negative 4 works as a solution. And the first thing we want to do is we want to figure out that least common multiple, that least common denominator idea. So what's the first thing I should do? Factor, right? Factor x squared minus 9. When I factor that out, it's a difference of 2 squares, so I get x minus 3x plus 3. So now as I consider all these denominators that are present, you've got an x minus 3x plus 3, Then you got an x minus 3 over here. The least common denominator is basically going to consist of those two factors, x minus 3 and x plus 3, right? So I'm going to take x minus 3 and x plus 3. I'm going to multiply that through the entire equation. I'm multiplying that to both sides. All right, when I multiply that 1 in the lead position, I'm getting x minus 3 and x plus 3. And if you want to go ahead and multiply that out, wouldn't be a bad idea. I'm adding on now whatever's left over when I multiply this next fraction. What's going to be left over? Just 30, right? Because these two factors here cancel with those two factors there. 30 is the original numerator, that's all that's left. Minus, okay, the only factor present in this fraction that we can divide out would be the x minus 3. So 5 is the numerator on top. That's going to get multiplied to the remaining factor of x plus 3. And obviously, when we multiply the other side, we just get 0. So we got a little bit of multiplying to do. FOIL this out. We know that's x squared minus 9 plus 30. Distribute the negative 5 through. That's negative 5x minus 15. Combining like terms, got x squared minus 5x. And then what we got here, plus 6, right? Is that factorable? If so, was it factor 2? Okay, x minus 3, x minus 2. Meaning our solutions for x, if we take each factor, set equal to 0, and solve, would be 3 and 2, 2 and 3. Do we have any issues? 3 is an issue. If you take 3 and you plug back in either here or here, you get 0 in the denominator. So 3 must go. 2 can stay. Okay, we're going to factor out our denominators. Let's see, when I factor the p squared minus 1, that's p minus 1, p plus 1 is a difference of 2 squares. When we factor the p squared plus 4p plus 3, well, that's going to be p plus 3 and p plus 1, right? All right, we got this guy over here, p squared plus 2p minus 3. Well, that's going to be what? P plus 3 and p minus 1. So, least common multiple based on the least common denominator, if I put all these fractions together, would consist of what factors? We've got 3 of them, don't we? Yeah, you got a p minus 1, you got a p plus 1. This does not look good, but I'll squeeze it in here. We got a p plus 3. We're taking all 3 of those guys, multiplying them through. Now, if you haven't caught on yet, every time we multiply these through, first of all, the fractions are going away. That's kind of the point. But the thing that always remains is those numerator expressions multiplied to any leftover factors. So p minus 2, that's the numerator expression for the first fraction, right? That's from this guy. In the denominator, we had p minus 1 and p plus 3, so that's going to cancel with the p minus 1 and p plus 3 there, meaning all you got to multiply on is p plus 3. We are subtracting 3 in this numerator. We know that's going to be part of this. Got p plus 3, p plus 1. meaning p minus 1 was the only thing that's not down there. Multiply that on. Right side of the equation, you got 2p minus 1. What's that get multiplied to? P plus 1. Okay, we start multiplying a whole lot of stuff out. Start shifting stuff from side to side. Got p squared here. Outside's 3p, inside's negative 2p, so that's plus p. Last, we've got negative 6. Distribute the negative 3 through. Negative 3p plus 3 equals, foiling on this side, we've got 2p squared. Let's see, outside is 2p, inside negative 1p, so that's plus p. And last is negative 1. All right, let's start shifting stuff together to one side. I'm noticing the quadratic forming, so I want to set everything equal to 0. I think it would make more sense to move to the right side, right, to keep that p squared term positive. So 0 is going to be on this side. Got 2p squared minus the p squared to bring it over, so p squared's left. Now here we have a negative 2p, right? So negative 2p, you're going to add 2p over, that's going to be plus 3p. Got minus 6 plus 3, so negative 3 there. Add 3 over to this negative 1, plus 2. This doesn't work out too bad, because that factors pretty nicely. Got your p's, got your 2, your 1, everything's positive, meaning our answers for p will be negative 2 and negative 1. Any issues with those? Negative 1 does not work. Negative 1 does not work because of the p plus 1 factors here. So we take that out. Negative 2 is the answer.